Our final person for this opening plenary is the National Technical Director for Molten Salt Reactors and our gallant leader for much of the MSR campaign is Dr. Lou Qualls, or as he refers to himself, Sweet Lou. Lou, you have the floor.
Okay, so that was recorded for all time eternal. That's good to know. Hey folks, thank you so much for attending. Thanks for the speakers. Thanks to DOE. Thanks to GAIN for the support for this. All of this is so important as a community to get together and see each other as best we can, interact with one another, share ideas, and keep growing the community and moving the ball forward. Greg, if you'll go ahead and show my one slide. What I want to do is explain my perspective a little bit on advanced reactor development, molten salt reactor development. This is a slide showing the energy consumption in the United States since its history. I love this slide. Energy Information Administration puts this out and updates it regularly. And it's just so informative, I think, as a community who are energy enthusiasts, to understand some of the history. And there's three things I want to point out about this particular slide. One is that it takes a long time for a new technology to reach maturity and saturation within a market. That can be as long as 50 years or more. So you have to understand, if you want something to be in the system and functioning in the system, you have to start early. And it takes some time. So if you notice there, the nuclear part of this chart takes 50 years to ramp up to maturity. And so it's going to be, something to consider as we move forward. But the other thing to notice is you can change things quickly if you really want to. You look at the coal plot there, you can see it turned down pretty rapidly. And that was sort of a decision that was made. We were going to use less coal. So we did change that very quickly. But when you give something up, you've got to use something else. And in this case, the thing that responds the quickest is natural gas. So you did make the situation better here, but you had to trade coal for natural gas in order to meet the demand. So that's one thing to notice. You can make changes quickly if you have the will to do so. But typically, technologies take a while to mature into the market. Things to note down at the at the renewable end of the spectrum is they too have ramped up quickly and are increasing in market share. And that is very positive news. Energy is like preaching, every little bit helps. So we expect to see growth in those areas as well. But the reality is, if you add up coal, natural gas, and petroleum, that there is a lot of energy to be made up, okay? And the only way to do that in a clean manner, that significantly, is nuclear power. So from my perspective, the molten salt reactor development is a near-term need for the nation. So I tend to think of things in a very applied approach. What can we be doing today? How soon can we get our first reactors running? How quickly can we learn from those? And how quickly can we deploy new reactor technologies for the market? And you hear the timeframes of interest, you hear the awards being proposed for builds within the next 5 to 7 years. All of that, aggressive near-term focus is very, very important. So that's the way we're approaching molten salt reactor development, as I know this community is as well. Okay, molten salt reactors, I think, are so powerful and flexible of machines. They can meet almost all of our U.S. energy objectives. But it is a little different. And when it is a little different, it takes a little longer to familiarize folks with what it is and why it's important. We've made a lot of progress in the last few years on that. And, having 500 people register for this workshop is an indication that the community understands that and is interested and excited about that. So that is very, very good news indeed. So I wanted to go over a couple things real quick, and then I'll hand it back off to David. But one of the emphases that we're going to have in today's workshop is to try to start the sessions on time. If we break a little early, we'll have just a little longer break, but we will try to start the sessions. We'll probably have a little time at the end of this session to fix a couple technical things that we might need to work on in the break, such as making sure everybody can sign in and hear, get the slides scrolling, things like that. So we'll check on the sign-ins, make sure everybody's in. I want to thank the moderators who are putting the work and the effort into this workshop. I'd like to say they all volunteered happily, but I volunteered a lot of them. And they have done a great job, and I appreciate their effort. And, you know, Alice said something that's very important, and I agree. What you're going to see today is a lot of the next generation, okay, who are being trained up in advanced reactor development and deployment, and who will carry this story forward after folks like David and I have retired, perhaps. But this training up of the next generation is vital, and you're going to see a lot of people within the campaign who represent that next generation. And I really do appreciate their efforts on that. Okay, with that, I think I will turn it back over to you, David. Thank you.
All right. Well, as Lou pointed out, we're going to try to stay on time for the agenda. So we're going to have a little bit longer break than we had thought. But one of the functions of this is we found that we like to have people drive their own slides when possible. They tended to be more interested in doing that. So during the break, we're going to ask each one of the presenters in the next session to go ahead and present their and to try their audio and visual. And the chair of the next session will be Ted Bessman, and so he's going to coordinate that in between the break to make sure that all the presentations work properly.
Hey, David, we had a question come in. Yeah.
We have our first question from the chat, and that one's for Alice Caponiti, from Dr. Hashimian, who would like to ask Alice to please elaborate on further DOE awards she said are coming by the end of the year.
Yeah, so the Advanced Reactor Demonstration Funding Opportunity announcement that was out this summer, all applications for that funding opportunity have been received. The application due date was August 19, I believe. But we are releasing those awards in phases. So our first phase of awards were for the 50-50 cost share demonstrations. Some concepts that applied to those 50-50 cost share opportunities, if they were not selected, have the opportunity to be reviewed for a 80-20 cost shared risk reduction awards. So these are risk reduction awards for future demonstrations. So we will be announcing awards for that pathway later this year. And in addition, there's a funding opportunity called Advanced Reactor Concepts 2020. And those are for less mature technologies that would be, you know, future demonstrators out in the future, but really addressing more fundamental technology challenges associated with their design. So we have those two pathways of awards that will be announced before the end of the calendar year.
All right, I am actually surprised that when we have several hundred people and we have the leadership from DOE, both technical and project, as well as GAIN leadership, and there are no questions. I did not think the MSR community was quite that shy.
Hey, David, there are two questions posted in the chat. One is for Alice.
Okay, you're going to have to read them because when I see the Q&A, right now mine says there are no open questions. So
Yeah,
Jordan,
they're posted in the chat, not the Q&A.
Okay.
Jordan, let me take this real quick.
Yeah, go ahead.
It looks like our chat isn't working quite the way we trained for it. And so we'll figure that out. And so panelists can use the chat. And if you're a panelist, you would see, you should show up there. And the Q&A should show up for participants. So one question was, what are the plans for distributing presentations? The presentations, if they are shared with us, and the speaker provides a form that allows us to share them, the presentations and the video can be shared with people. So we will break these presentations up into single videos, and we can send both the presentation slides and the video if we get the signed form from presenters allowing us to do so. And some will not be able to do that. We can direct you to participants individually, and you can ask them to send it directly if they don't send that. One of the questions for Alice, what's in the chat box, was, is it likely some of the future awards will go to MSR designs?
Well, that's really up to the community to have applied, right? So we'll look forward to making those announcements later.
Yeah. All right. Okay. And so with that, during our break, we'll try to figure out the chat a little bit and get everything.
We do actually have some Q&A that have gone into the Q&A box now.
Okay.
So,
take over.
So the question is, will there be any considerations for gain vouchers to support universities doing work for companies?
Okay, hi, I think that's for me. So at this point in time, there are a number of avenues for funding work with universities, and the gain vouchers are not open to that. But if you are, if you need some help identifying what those opportunities are, please call the GAIN team so we can help you get connected to the right places. We do watch across the entire DOE complex, different funding opportunities, the types of technologies that they're looking for. So whether it's a GAIN voucher or not, we can help you get connected to the right place.
And if you don't mind, I would like to add, at the Office of Nuclear Energy, up to 20% of our funding for research and development programs goes toward university awards, and industry can certainly partner with universities in those projects. So please look for those opportunities as well. And that funding opportunity is posted at the GAIN website.
Okay, next question is, what are plans to actually build MSRs in prototype size, not just loops and running codes at the labs? Or are there only commercial efforts out there? That's either Alice or Lou, probably, either one of you two.
Well, I'll say this, we only learn by doing. And so I would say, let's get on to building things that look like reactors and are reactors as soon as possible. But that's driven by the community, right? So we have to have good strategies, support from industry, and DOE will be supportive as well. But those timelines are up to developers, I think. Our job is to help facilitate their success and make it possible as soon as we can do that.
Then next question's from Raluca Scarlat at UC Berkeley. And her question's about workforce development. In terms of workforce development of nuclear engineers trained on MSR/FHR technology, is the workforce growing at the rate needed by industry? I'm not sure who gets to answer that, because because I think industry is going to have to tell us whether they think there are an adequate number of people, and that's most of the tomorrow afternoon. And so unless someone else would like to comment on that, I think I'm going to hold and ask that as one of the things that we're going to ask the folks in industry, whether they think there are enough people coming in.
I would love to add one quick thing that there is that every major nuclear department has MSR activities going on. We get contacted all the time about people wanting to participate in MSR research. So it is widespread, I think, and it is gaining momentum, and we need to find ways to get sustained funding to that as well. But certainly the enthusiasm is there for it, and the students are there for it, and the young scientists at the labs are interested in it.
So to further comment on that, GAIN is co-sponsoring with DOE next week a Nuclear Tech Connect specifically aimed at enticing people into nuclear engineering, into the nuclear field in general. And so next week, October 21st and 22nd, we're doing it as part of National Nuclear Science Week. So I think not only having the enthusiasm that's already there, Lou, I think it's about sparking some new enthusiasm as well. So we are, GAIN and DOE are actively looking at how we make sure that we build out the pipeline.
All right, I believe that's all the questions that we have for that the panelists are appropriate to answer, and so in which case I'm going to call a close to this session and say in about 10 minutes we're going to start testing the connections for the next session, and we'll be going promptly from there. I have gotten a question posed as to what my background image is here. And so I'll let you guys know that this is back in the late 1950s. This happens to be a spot where we were running 15 pumped molten salt test loops simultaneously. And we actually were running 20, and they're just not all in this picture. And to let you know that there is a substantial technical heritage to build from, and we don't have to recreate the wheel for this. They were really doing very important work. Alice mentioned this in her presentation, the heritage that we're building from, and it is a very substantial heritage. And I point out in most of my talks about the MSRE, the reason it worked so well is that it had 15 years of people doing massive technical demonstrations and really substantial work prior to turning it on. And that was largely why it worked so well. Otherwise, I will take you into break.